Welcome to this first tutorial as part of the Euclid's Elements Redux project. We're going to be taking a look today at some of the basics of using GeoGebra. It's the software package that I used to create the figures in Euclid's Elements Redux. I chose it not only because it's powerful, but because it's open source, which means that anyone with a computer, their own computer at least, can download it and use it for projects of this type. Now there are many different ways to use GeoGebra, and I'm only going to use some of the most basic. But I'd want to show you a bit of how to get up to speed because it is an interactive program. It's not terribly easy to run scripts on it, at least not the way I have been using it. I'm sure there are others out there who disagree with me, and that's fine. But I want to go through the basics and show how to create the figure from Euclid's First Proposition, Book 1. Now as you see, the screen here is blank. You might actually have axes and grids already set up on your particular GeoGebra application. Either way is fine. You can turn those on and off under View. When you're actually viewing a figure, it's better to have them off, but when you are composing a figure, I have found it's better to have them on, so I recommend that. We have a number of tools up here. If you're at all familiar with basic geometry, and by that I mean if you've got a basic idea of what's going on in 7th grade geometry, this isn't too bad. It really comes down to your willingness to point and click and try out different things. There are a few tricks with this, which we'll go through. One tool we have right here in the middle is our circle tool. You see, you have a number of different ways to create circles, semicircles, and so on. We're going to use circle with center through a point. And what I'm going to do is start over here at the point -2, 3, and create a circle of radius 2. You'll see the very first point that it creates is called A, the second is B. That's normal for how GeoGebra works. If we were to create another point, it would be C. What we're actually going to do is create a second circle. Again, we're working with proposition 1,1. And the whole point of this particular proposition is to show that we can construct an equilateral triangle. Now the actual proof of this is not really what I want to go over, except to say it is proposition 1,1 of my edition and any other edition of Euclid. It's very standard. Coleridge even wrote a poem about it, believe it or not. But the idea is we have two circles with the same radii but different centers. And what we're going to do is put the two centers of the two circles the distance of the radii away from each other. So in this case the radii is 2, so the centers are 2 units apart. How is that going to help us? Well, we're going to use another tool, our polygon tool, to create an equilateral triangle. And I'll click on A and B here, and then what I'll do is move over here a little bit so you can see it. No, it's not going to do it today. It's not fair. It's alright. I'll click on where I believe to be the intersection of these two circumferences. And of course, GeoGebra guesses pretty well. Notice it's not done yet. It doesn't know if I want a triangle or quadrilateral or what. I'll click on B again. Notice how I get close to B. You can see it a little better here. It just snaps to B. So it's intuitive in that sense. And that creates my equilateral triangle along the lines suggested by Euclid 2,300 years ago. Now, is that all? Well, not really. We can change our view here, try to get a better idea of what's going on by getting rid of some of the clutter. We can use this tool over here, move graphics view. We can also use our tools over on the left. The move tool, for example, allows us to click and drag on the labels, move those guys around to get a better picture. So you don't have to stick with the initial placement of any letter or anything else. In fact, if you did not want A, B, and C as your labels, you have some options. Anytime you've chosen the Move tool, you can double-click on an object, such as point C, and it says that it's a certain type of point. It's an intersect point. So within the software itself, it knows it's intersecting those circumferences. And by clicking on Object Properties there, you can see we have a name, and I could choose a different name altogether. Why I chose Fred, I don't know. Basically just to say it doesn't have to be a letter. It can be anything you want. Of course, you do have to move things around a bit if you change the name from a single letter to a word and so on, but that doesn't really matter. I'm going to change this to H. So, like most programs, you would not expect to be stuck with whatever default name that was given to the object. You can move things around. As you see, what I've done here is actually clicked on the point I, and I'm dragging it around, so I'm not even stuck with the original points I chose. I have that much freedom, although I'm going to use Control-Z to put it back. Now, once you have something that looks pretty much the way you want, File, Save, and you're going to save it as a .ggb file. Many times, though, you won't want a GeoGebra file like what I just saved. You actually want a graphic. So again, we're going to click and drag using the Move tool and go to Export. Now, you can see there's a bunch of options, including graphics view as animated GIF. So there's a lot more than I'm going to show you. Since I'm coming up with figures for a book, at this point I'm not planning on animated GIFs. Perhaps that will change. But for now, I want to show you graphics view as picture. You can see we've got a couple of options here: PNG, PDF, EPS, SVG, EMF. SVG you can see a couple of different places. One is Wikipedia. Wikipedia has a number of really good math pages, which I recommend. As far as printing for books, EPS is the standard, because when I say standard, I mean math books. Math books love LaTeX, or in my case, LYX, LYX. And it's just easiest to save as an EPS file because it saves the information on the shape of the file. And this will be saved as test EPS. So that's the basics. Hope you enjoyed it, and I plan to do more tutorials later.